All right. On the back of your worksheet, you notice something that says disjoint or overlapping events right here. So we're going to end up doing number 11 together at the end of this. But I want to talk about, before we get there, what is a disjoint versus an overlapping event. And so disjoint and overlapping events are known as compound events because we're looking at multiple things at the same time. And we have, like the worksheet says, we have two types of compound events. The first one is known as disjoint. It's also known as mutually exclusive. So a disjoint or mutually exclusive compound event is defined as two events with no common outcomes. So what this might look like is like the probability of spinning a 2 or a 5. Okay, so if we're looking at our spinner here, what is the probability of a 2 or a 5? Okay, so we could look at this a couple different ways. What is the we can look at it, what is the probability of spinning a 2? And what is the probability of spinning a 5? And we can add those together. Because there's no way that I can spin a 2 and a 5 at the same time. So I have to look at them separately. So the probability of a 2, well, 2 shows up once, so that would be 1 out of a possible 8 that I could land on. Same for the 5. 5 shows up once out of the 8. And then I'm just going to add those two together. Since they have common denominators, that would be 2 out of 8, which would give me a reduced probability of 1 out of 4. So I have a 1 out of 4 chance of landing on a 2 or a 5. The other type of compound event is overlapping. So if I have an overlapping event is an event where at least one outcome is common or shared. So that might look something like the probability that I'm going to land on a multiple of 2 or multiple of 3. Okay, so I'm looking for a multiple of 2 or a multiple of 3. And so it becomes overlapping because I could have a number that is both a multiple of 2 and a multiple of 3. Okay, so the first thing that I have to do is I have to figure out what is the probability that I'm going to have a multiple of 2. So having a multiple of 2, I'm going to color coordinate this. So 2 is going to be in gray here. So a multiple of 2 on my spinner would be 2, 4, 6, and 8. So everything that has this gray dot is a multiple of 2. So I ended up with 4 out of my 8 spinner selections being a multiple of 2. It also says that I want a multiple of 3. Okay, so I'm going to make multiples of 3 in this pink color. So my multiples of 3 would be 3, 6, and that's it, because the next one would be 9. Okay, and so I ended up putting 2 dots on 8 of those. Okay, so I found the multiples of 2, found the multiples of 3, but if I have any outcomes that are shared, which you notice that 6 has 2 dots on it, 6 is shared in both the multiples of 2 and the multiples of 3. So I have to subtract from this compound event the probability of having a multiple of 2 and 3. Okay, so out of all of the ones I put dots on, only one ended up out of the 8 of being a multiple of 2 and 3. So I need to add together my 2 separate events, the multiple of 2, multiple of 3, but then I also have to subtract away anything that overlaps with 2 and 3. So if I add these together, and notice I kept them all in the same denominator, 4 plus 2, that gives me 6. Again, keep the same denominator of 8, and then subtract away that one common piece that both of these have, and that gives me 5 out of 8. So I have a 5 out of 8 chance of landing on a multiple of 2 or a multiple of 3. And that should make sense, because if I look at my wheel up here, I have dots on 1, 2, 3, 4, 5 of that particular wheel. So I said that we were going to take a look at number 11. So go ahead and get your worksheet out, and let's take a look at number 11. Okay, so it says, if you are picking a number between 1 and 20, what is the probability that you will pick a number greater than 14 or less than 4? So the first thing we have to think about is it going to be disjoint or is it going to be overlapping? So for visuals, I'm going to put numbers 1 through 20 up here. 1 through 5, 6, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to spread them out here, 18, 19, 20. Okay, so there are all of my numbers between 1 and 20. So we need probability that we're going to pick a number greater than 14, and we have probability of a number less than 4. So here are your numbers greater than 14. Well, 14 isn't greater than 14, so I would have 15, 16, 17, 18, 19, and 20. And it says or less than 4. So 4 isn't less than 4, so I'm looking at 3, 2, and 1. Okay. Do any of the numbers that are greater than 14 also show up over here for being less than 4? If the answer is no, then it is a disjoint. They're not connected. If you do have any that show up in both groups, then they're overlapping. So this would actually be a disjoint group because none of these numbers are going to show up over here. So now all we're going to do is just add these probabilities together to get our probability of either this or this. So our probability of greater than 14, we ended up with 1, 2, 3, 4, 5, 6 out of 20 possible. And for 4, we ended up with 3 out of 20 possible. And again, I'm just going to leave that bottom number the same because it's easier for us to add. So then all we have to do, add those together, and you get 9 out of 20 is the probability that you're going to end up with a number greater than 14 or less than 4. But remember, if we did have something that overlapped, we would then have to subtract away that common piece. So you are to finish the rest of this worksheet, 12 and 13, with disjoint or overlapping events, and any problems on 1 through 10 that you didn't get with the experimental or theoretical probability.